Welcome. We want to take a look at an example of combining functions and finding the domain when we combine those functions. So we're talking about the algebra of functions, adding, subtracting, multiplying, and dividing. We'll look at 4 examples here. We're using the function f of x is the square root of x plus 6, and g of x is x minus 2. So we'll find each of the following combining of functions and the domain of each. Very conveniently, the domain is almost exactly the same in each case. For f plus g of x, we know this is f of x plus g of x. F of x is the square root of x plus 6, and g of x is x minus 2. So we can leave it just like that. The parentheses are fine. This looks good. To find the domain of this, we need to first find the domain of f and the domain of g. For the domain of f, we need to have that x plus 6 is greater than or equal to 0 in order to take the square root. That gives us x is greater than or equal to -6. So using interval notation, we would say that the domain of f is precisely from -6 to infinity. Now, if we wanted to look at the domain of g, that is even easier, right? The domain of any polynomial function is precisely all real numbers. So that's -infinity up to +infinity. All right. If I want to consider then the domain of f plus g of x, that is simply whatever these two things have in common. Now, sometimes you maybe will want to graph these on a number line, right? One above, one below, and then look at what they have in common to help you observe that. But in this case, -6 to infinity is just a subset or completely contained inside of all real numbers. So we would simply say that it is the same as the domain of f, which was -6 to infinity. Excellent. Now I can continue on, and the following couple of examples will use exactly the same domain. F minus g of x is f of x minus g of x. F of x is the square root of x plus 6. G of x is x minus 2. Now, in this case, maybe it would be nice to distribute the subtraction into the parentheses. Maybe. You could probably leave it as it is. Otherwise, you might want to write it as x square root of x plus 6 minus x plus 2, and that would be fine. Here, the domain of f minus g is exactly the same as the domain of, let's see here, domain of f minus g is the same as the domain of f plus g. Right? There's no additional concerns because we don't have that concern of division by 0 as we do with the quotient. So it's the same for addition, subtraction, and multiplication. F times g of x is f of x times g of x, which is the square root of x plus 6 multiplied by x minus 2. By convention, I would say that we write the polynomial in front of the radical here. So we would maybe typically write this as x minus 2 times the square root of x plus 6. There's no real good reason to do that, again, aside from convention. The domain of f times g of x, again, is the same as it is for addition and subtraction. So -6 to infinity, and life is good. The only place that things look different is for the quotient, f divided by g. You can think of this as f divided by g, right? Same phrase because it's the same thing, of x. That is f of x divided by g of x. That's our definition. And now we would look at that as the square root of x plus 6 being divided by x minus 2. Now we can't divide by 0, so we want to remove the points where x minus 2, that is g of x, is equal to 0. So to be clear, again, this is g of x is equal to 0, the denominator. We can't have this. Add 2 to both sides to find that x is equal to 2 is the thing that we need to remove. And I need to remove it from this same domain that we've been working with. So if I wanted to do that, I would say that the domain of f divided by g is given by, so I'm going to go from -6 all the way up to 2, but I'm removing the point 2, so I'm going to use a parenthesis that indicates that I am not including that endpoint, and then I'm joining that, right? I'm not picking up at 3 because that would miss a whole bunch of values. I can certainly plug in things like 2.2 or 2.1. So I'm going to pick right back up at 2, but I'm again using that parenthesis to say I'm not including this endpoint. And then it will still continue on to infinity. And that looks good. Excellent.